record. Okay, we're recording now.
Yep.
All right, some introductory stuff. All right, so I'll just talk quickly about the test, but I think I've given you everything I need to say and I replied to you. Okay, so quick word about the test. You should have gotten your score back if you provided me with homework and on time. Okay, so if you didn't get a score from me, you either submitted no homework or insufficient homework or it wasn't on time. Remember I mentioned, and I'm sure I mentioned it many times, that you had to submit the homework in order for me to give you a grade. And if not, I don't give you a grade, which means it's left as a 0. Okay, however, you get to drop one exam. So if you missed this exam or if you didn't submit any homework, it counts as a 0 still, but you get to drop one exam. So that's the good news. The bad news is if you drop this exam, that means you can't drop any of the other ones, right? So you've sort of lost that lifeline, so to speak. Okay, most people did okay. People who took the test and submitted homework were fine. Okay, so low grades were almost always because you didn't submit homework or insufficient homework or it wasn't on time. Okay, so remember, there's that 70% requirement. If you don't submit the homework, at least 70% on time. On time means half an hour after class ends, then your grade doesn't count on the test. I don't grade it. It counts as a 0. Okay. So that's that. The other thing I wanted to mention is I think I've successfully gained the day that I was looking for. So tentatively, I'm moving all the days of the entire semester up. Okay. Now, I'm not quite going to write it all in because in case I mess up, but technically, everything is moved up a day. So remember at the beginning, I said I thought we were going to end on May 25th, and that's not true. We're ending on the 20th, so I have to gain a day somewhere. I was successful in gaining a day up here, so to speak. Okay, so I already did 6.1, right, last Thursday. So here's our schedule leading up to the next exam. Okay, so today is 6.2, 6.3, 6.4, 6.5, and then exam 2. So our second exam, we're aiming for February the 18th. If I do one section a day. Okay, you've seen one exam now, so you know my style. Again, my grading is 90, 80, 70, 60. So 90% an A, 80 is a B, 70 is a C, 60 is a D, less than 60 is failing. Okay, and you want to start building your next formula sheet, as it were, leading up to the second exam over here. In case you're wondering, we're not having a quiz today. I rarely give a quiz the same week as a test. You know, it's too much. So the next quiz might be next Thursday, I suppose. Okay, so I'm not going to give you a quiz today. Okay, so we're on to 6.2. So this is a tentative schedule for now. I'll raise it up a little so you can mark it down. But basically, it's move everything up a day. I gained it. Well, you can't change this flex day, of course. That's still up. But, you know, I was looking to gain a day, so I was able to gain that day over here. Okay, so here's our new schedule. I asked you to do 6.1 already after the test on Tuesday, right? So hopefully you did that. And I changed the assignment on it, and I'm changing the assignment for 6.2. Okay, so 6.1, it was only going to be 1 to 10 odd. So it's not that much. I'm even changing 6.2 because I have inconsistency even with my notes and homework. Okay, so for my book, it's going to be 5 to 16 odd. And that's even going to be different than what I'm going to show you. It's all messed up because I can't go to City College and get the book that I'm supposed to teach you guys out of. Okay? But again, it should not be an issue, right? Whatever book you have, the formulas are the same. The problems may not be the same, but just do enough of the type of problems and go from there. Okay? So 6.2 is going to be 5 to 16 odd. And again, the ones that I'm going to show you may not even match the book, but it doesn't matter. You don't have the answers to the even answers anyway, and I'm going to be mostly doing evens. Okay, so that's where we're at. Okay, and I see some stuff in the chat, so why don't I address the chat right now real quickly. Okay, so is that 5 to 16? Yes, 5 to 16. Yes, odds. Odds are 1, 3, 5, 7, 9. So 5 to 16 odd means what? 5, 7, 9, 11, 13, 15, and so on. Okay. If you just joined, put that you joined in the chat because I already took roll. Okay, so put something like that. Okay, so odds are 1, 3, 5, 7, 9. evens are 2, 4, 6, 8. The ones that I will do for most of my demonstrations from here on out are evens, 2, 4, 6, 8, 10, because there aren't even answers in the back of the book. Okay, so that wouldn't matter, so to speak. Okay, yeah. So if you missed roll call, just put it in the chat. I'll get it later. I already put away the roll, but I'll get it from the chat later since I can look at the chat somewhere later. Okay. All right. So before going on, the first thing I want to talk about is giving you all the formulas that you might want to have for the next exam. Okay. So pay attention to this. I think we're recording. Let me double check. Yeah, we're recording. I can't tell if we're recording until I stop sharing, unfortunately. So let me go back and share. Yes, we are recording. Okay, so please check this out first before I start. Now, you want to have your calculator handy. Okay, this test is very much calculator dependent. I think I said that. Okay, and there's two kinds of calculators: a fancier calculator and a not so fancy calculator. Again, in our class, you're not going to be able to get by with just a 4-function calculator. Well, you already know we've done logs, exponentials, and stuff like that. We'll be doing quite a lot more of this. Okay, so this chapter is pretty much financial math. Okay. Now, when it deals with money, how should you always round your answer for money to the nearest cent, nearest penny. Okay, so you should not give me $316.521414828. Don't give me that. You round it to $316.21 or something like that, or $1,013.58. Don't give me 0.58042. Okay, you should know that there's no money that goes out that far. Okay, and yes, unless we say otherwise, it's dollars and cents. We are in America, so we're not doing money that's in Spain or China or Vietnam or Russia or whatever. It's American money, so dollars, cents, nickels, dimes, and so forth, because we're in the United States. Yes, I realize some of you are actually not in the United States. I know some of you are calling in. You're not on the United States soil. Some of you might be literally in China now, or Taiwan, or some other country. I get it, but you're taking a course, a United States course, so everything I talk about will be United States based. Okay. All right. So take a note of all of these formulas. You can mark it down or not. You can, just get it from the video later. Okay. So 6.1, I gave it to you last time pretty much. So 6.1, in my book, it's on page 362. Formula for simple interest. Put this on your formula sheet if you wish. Interest equals principal times rate times time. I gave that to you last Thursday, I believe. And at the time I said, okay, don't look at it carefully because you're focusing on the test. But now the test is over. Okay, so I stands for interest. P is principal in dollars. That's the amount you invest. R is an annual interest rate. They give it to you as a percent, you change it to a decimal. So like 5% is 0.05, right? Time is always in years, so if they don't give it to me in years, you change it to years. Put that on your cheat sheet. Page 363. S equals P plus I. Future value, they use S for the future value, is principal plus interest. Okay, and yes, I'm actually going to, well, I gave it to you before, but I'll write it here. You could also write it as P plus PRT. Now, we just said that I equals PRT, right? So how about over here? I just change I to PRT. So another formula for S is P plus PRT. And another one, you can factor out the P. So P times 1 plus RT. So you may put all of these on your next cheat sheet. They're all equivalent. Okay, so future value S is principal plus interest. That's the most basic one. Or principal plus interest. Here's interest, right? PRT. Put equal here. And if you factor out the P, you have 1 plus RT. All right, so that was last time. Now, section 2, what we're learning today is compound interest. Again, I've already done simple interest, but if you have questions for it, maybe I'll take it later. So compound interest. So I'll talk about compound interest today. 6.2, compound interest. We're not talking about geometric sequences. Okay. So compound interest formula on page 370. S equals P times 1 plus R to the n power. Okay, P is principal, the amount that you plunk down to the banker. Okay. And there's actually a variation of that formula, which I will show you here. And actually, you know what? I take it back. You don't really need this formula. I think it will confuse you. Scratch that. Okay, so forget about that. This one's much better. It covers it also. So page 371. Okay, this one here, S equals P times 1 plus I to the n power. Now, this one is true. This one is true. I don't think you need it. Okay, so I is interest rate per period. And I'll give you many examples of that. Interest rate per period. It's not the annual interest rate. It's interest rate per period. Okay. And the exponent here is n. N is the total number of compounding periods. Total number of compounding periods is n. Yeah, they give you these formulas. You can put it or not. Okay, I think you can survive without it. Okay, to me, if you understand what's going on, that lasts longer, so to speak, than just memorizing another formula or cramming another formula. So the one you absolutely need for this section is S equals P times 1 plus I to the n power. This is true. You don't really need it. Okay, but the I is a rate per period. It's not necessarily the annual rate, although it might be. Okay, and that's really the only one you need for this section. Okay, now section 3. We're not doing section 3 today, but just so you can have it. Okay, so section 3, something called future value of annuity. I'll talk about what that's entailing. I don't know why it's yellow, but that happens sometimes, as I say. Okay, and here's the funny formula for this. Page 384 of my book. S equals, let's ignore this thing. Don't even look at that. Don't need it. Okay, then you have this messy formula. S equals R times 1 plus I to the n minus 1 divided by I. Okay, S is a future value, just like before, future value of an annuity. We'll talk about that. R is called a periodic payment. It's a payment that's made every period. Period might be weekly, monthly, semi-annually, quarterly, whatever. Fortunately, this I and this n are very similar. I is the interest rate per period, and n is the total number of compounding periods. Okay, and you say, this is going way over my head right now. Don't worry. I'll talk about the I and the n. The I and the n are the same for section 2, section 3, section 4, section 5. So hopefully we get the idea of the I and the n from today's section. The same concept applies to 6.3, and the same concept applies for 6.4, and the same concept applies for 6.5. Okay, so here's the formula. Put it in your cheat sheet. Don't memorize it. You don't need this. It's true, but it's extra. We don't need it. So S stands for future value. R is a periodic payment, okay, whatever that means. Okay, or if you want to just copy this whole thing, it's fine. R times this funny fraction, 1 plus I to the n minus 1 all over I. It's called future value of an ordinary annuity. Try to focus it better. Okay, that's the only formula you need for 6.3. 6.4, present value of an annuity. You're saying, yeah, my head is dizzy. I don't understand all this stuff. Yeah, we're not doing all this now. We're only doing one thing at a time. Okay, so we'll worry about it when we get to it. 6.4 is now going to be what? Whoops, wrong paper. 6.4 is now going to be when? Next Thursday, I guess, February 11th. And here's the formula, page 393. A sub n, it's called present value of an ordinary annuity. So A sub n, present value of an ordinary annuity, forget this. R is again a payment. It's a payment man in the end of each period. And then you have a funny fraction. It looks kind of similar to the previous one, but some things are the same, some things are different. 1 minus 1 plus I to the negative n. That's new. There's a negative exponent there. 1 minus 1 plus I to the negative n, divide the whole thing by I. Okay. Again, A sub n stands for present value of an ordinary annuity. This R is similar to the previous section R. It's a regular payment, periodic payment. And then this funny fraction, 1 minus 1 plus I to the negative n divided by I. Okay, and then section 5 is actually the same formula. It's the same formula. Okay. Section 5, we're dealing with loans, like when you take out a loan, car loan, home loan, something like that. Loans and amortization. Okay, so what is amortization? Okay, that's when you finance a payment. So, oh, you owe so much money for a car. You owe so much money for a house. I can't pay all that amount. So you borrow some money. Okay, then you have something called an amortization table. Okay, so you pay it off in periods. Okay, there's one thing that I want you to have on your next cheat sheet. It's on page 406. It's this table at the bottom of 406. Okay, I'm not going to hold it that long. I'm certainly not going to let you copy it all down. That takes too long. Okay, so if you happen to have my version of the text, it's 406. If not, here it is. Look at the video later. Okay, copy this out. This is an example of an amortization table, okay, where it's got periods. Here you pay off the loan in 5 periods. It's usually not that short, but I'm not going to make you have a super long one. Okay. When you buy a home, if you buy a home, do you know how it's often amortized? It's often 30 years, sometimes 15 years. I've seen 20 years, okay? In which case, 30 times 12 is 360. This thing would be 360 down. Of course, they would make you put it on a spreadsheet, like an Excel spreadsheet. Okay, but you make a periodic payment. You pay interest. There's a balance reduction and an unpaid balance. Okay, we will learn how to do this thing. Okay, that's going to be section 5, the main topic of section 5. Side note that I just mentioned now, again, don't stress out right now about it. We're not supposed to do 6.5 until, you know, what, Thursday, whoops, where am I? Tuesday the 16th now. Okay. But I'll just mention quickly, here you're borrowing 10,000. What do we end up paying back? 13,000 plus. And so that amount is interest. That's the way it always is when you borrow money, right? You end up paying back more in the long run. Is that right? So if I borrow 10,000, after all the payments, I end up paying 13,000. It's always that way. Okay. Hey, the bank's out to make money, right? Now, if I give the banker the money, okay, then I earn interest also, right? So I give the bank the money, and then the bank turns around and lends it to somebody else, right? So I told the banker, okay, here's the banker, so make my money grow. Last time we did simple interest, right? Interest equals principal times rate times time, okay? And now we have compound interest, and that's more normal. Okay, usually when you put money in the bank, right? So I put money in the bank and say, banker, make it grow, okay? And then you earn compound interest, which I'll show you today. And you earn a certain percentage, okay? So the bank takes your money, gives you a certain amount of interest, and then they immediately take that money and loan it out to somebody else who wants to buy a car, a house, or whatever, okay? And as you might guess, the interest that the bank gives you, willing to give you, is less than the interest that they're going to cut from someone else. Hey, the banks are out to make money, right? So they might be willing to give you 1%, less than 1%, frankly, now. They turn around and charge you now 3.5%, 4%, 5%, 6%. Okay, that's what banks do. Okay, take your money, give you smaller percent, then you turn around and take that money and lend that out at a higher percent. So the banks make money. Okay, so that's the way it always works. Okay, so now I'm going to go talk about compound interest. Okay, so that's everything you need. Start putting down in your next cheat sheet. Those are all the formulas. So have everything I have as I showed you as a minimum. I'll probably show it to you more than once. And then you can put any sample problems that you wish. All right, so here we go. 6.2. Again, ignore the date. Compound interest. Under compound interest, last time we did simple interest. Okay, and if I finish early today, which I think I will, I'll let you ask questions about simple interest and compound interest. Under compound interest, we take our interest rate and divide it into a certain number of equal pieces throughout the year. Okay, so I've got it here. I'll hold it for a little while. You can write it or you can just look at the video later. Okay, but the concept is you take the percentage and divide it into a smaller number of pieces, equal pieces throughout the year. So last time when we did simple interest, right? Okay, interest is principal times rate times time. You just take the 10% or 5% or 7% and just go with it. Okay. Now, however, we take that percentage and depending on the compounding period, we chop it up into so many pieces. Okay, so here's an example I have. Okay, I'll hold this again a little bit, raise it up so you can see it. Okay, let's suppose the interest rate is 12% per year. Where'd you get that from? I just made it up, and it's convenient because it's easy to divide by 2 and 3 and 4 and 6 and 12 and stuff like that. Okay, so I made a little table here of what happens. Okay, 12% per year. Okay, I hope you've been able to get this. Again, you can watch the video later. Okay, now, if you have annual compounding means 12% per year. So you get the whole 12%. The number of periods per year is 1. Okay, this is the little letter I, and that's the letter N in the formula. Okay, so the formula in 6.2 we're doing now, if I can find it, S equals P 1 plus I to the N. This is the I, and this is the N. Okay, so annual compounding, let's say January 1. January 1, you get the whole 12%. That's all, no more, goodbye until next year, right? Semi-annual, twice a year. So I take the 12% divided by 2, and that's 6% or 0.06 twice a year. So it's as if to say, okay, here's how I will give you the 12%. January 1, 6%. July 1, 6 months later, 6%. So that's how I will give you the 12% per year. I chop it up into 2 pieces, 6% each. Is that right? Quarterly. Quarterly means 4 times a year. Number of periods per year, the N in this case, is 4. Okay. So every quarter, you know, spring, summer, fall, and winter, 3%. Okay. So January 1, 3%. April 1, 3%. July 1, 3%. And then where are we? What's next? October 1, 3%. That's how I will give you the 12% per year. Get the idea? You're just dividing it up. Okay. Monthly, as you might guess, divided by 12. So what's 12% divided by 12? 1%. So 0.01, 12 times a year. So the first of every month, let's say. So maybe the bank says, okay, here's how we will give you 12%. 1% on January 1, 1% on February 1, 1% on March 1, April 1st, and so on, all the way throughout the year. And the last one is daily compounding. Okay, daily compounding, I take the 12% and divide it by 365. It's a very small number. I don't feel like punching in my calculator. You can do it. You see, it's a very small number, but you are getting that very small number every single day, 365 days a year. So I take the 12%, chop it up into 365 pieces. It's 0.00, very, very small, but you're going to get it every single day, 365 times. Okay. A lot of banks do daily compounding. Okay. The account that I have is daily compounding. It's fine. So, you get a little bit every day. You can see the calculation is not that good. So for the exercises that we're doing, the most usual ones are going to be semi-annual, quarterly, and monthly. And I don't think we do too many others. Okay. Annual, you don't divide it up into anything. Just leave it as, the full percentage. Semi-annual, divide by 2. Quarterly, divide by 4. Monthly, divide by 12. So most of the examples that we will have will be this. And I'll just quickly also say that when you get an actual interest rate in the bank, the numbers are not that nice. I picked 12 because it's nice, but they might give you, 5.65%, and that's already bad. Then you have to divide it by 2 and 4 and 12 or 365. It gets real messy. But of course, the banks have it in their computers. The computer can do it very accurately, and so on. Okay. Right. So let me give you some examples here from the book. Okay, and even these may not match what's in the book, but that's okay. Okay, so the first examples are just getting used to figuring out the interest rate per period and the number of periods. Okay, so look at what they have for 5, 6, 7, and 8. So they will say blah, blah, blah percent for so many years, right? Compounded quarterly, monthly, semi-annually, and so on. Okay. The examples that I'm giving you may not even match, but that's okay. I should show it to you again, right? So I didn't show it to you. So what did I say? 5 through 16 odd. Okay, so there's 5 through about 13. It's on page 380. So if you never want to get the book, so that's 5 through about 13 or so. And that should be able to show you up until 16, I think. And I think we're good. Okay. So my number 4 from a different version. Okay. 12% compounded monthly for 3 years. 12% compounded monthly for 3 years. What's the I? This is not the I. Okay. The I is divided by monthly means 12. So 12% compounded monthly means take the 12% divided by 12. 12% divided by 12 is 1% or 0.01. So the I that you're plugging into the formula is 0.01. And now what is the N, the total number of periods? Okay. 3 years. How many times per year? 12, because it's monthly. So 12 times 3, 36. That's what you plug in to the formula. S equals P times 1 plus I to the N. Okay, so watch out. If they say 12%, don't automatically put 0.12 here. Yes, you have to change it to a decimal. 12% is 0.12, right? 6% is 0.06. You guys know stuff like that, right? So if it says 12%, don't automatically put this in. You might have to chop it up into so many pieces, right? So semi-annual, chop it into 2. Quarterly, divide by 4. Monthly, divide by 12. Annual, you don't have to chop it up in anything. So if it said annual, then yes, you would put the entire 12% or 0.12 there. Okay. And the N is the number of years, 3, times the number of times per year. Monthly means 12 times a year. So 12 times a year times 3 years, 36. So 36 would go up here. Is that right? Okay, my number 6 said 10% semi-annually, 8 years. Okay, find the I and the N. What's the I and the N? Okay, don't just put in 10% or 0.1. Semi-annual means I divide it into 2 pieces. So 0.10 divided by 2 is 0.05. Now, what's the N? 16. Now, how'd you get 16? 8 years. How many times a year? It says semi-annual, right? Twice a year. So 2 times a year for 8 years, 16 total, right? Year 1, do it twice. Year 2, do it twice. Year 3, do it twice, and so on. All 8 years, it's done twice. So 8 times 2 is 16. Okay, so now I'm actually going to do some problems, but the numbering is off. Okay, so I'm going to do, it says 8 on my paper, but I think it's the book's 10. Yeah, but it might be even different in different editions. So, sorry, the numbering is way off here. So number 10. What is the future value of $8,600 invested for 8 years, 10% compounded semi-annually? Problem 10, which on my paper is going to be 8. Okay, so $8,600, that's a principal, 8 years, 10% semi-annual. So I got it all written down here. Okay, so the number is wrong, but these are okay. Investment is 8,600, so 8,600 goes here. 10% semi-annual. Okay, semi-annual means how many times a year? Twice a year. So that means I take the 10% and chop it into 2 pieces. So that's 5% or 0.05. Okay. So again, don't automatically put 0.10 here. Okay. You have to chop it up. The chopping is in 2, so 0.05. And now what is the N, the total number of periods? Okay, 8 years. Semi-annual means twice a year, 16. So my N is 16 over here. Now I throw that in. So the S, future value, is P. 8,600 goes here. 1 plus I is 0.05 raised to the 16th power. Okay, and this is what I got. And I'll try to show it to you in my calculator too. So 8,600 times 1.05 exponent 16. 8,600. Okay, on my calculator, exponent button looks like that. Make sure you do it in your calculator. 18,772.72146. So how should I round the answer to the nearest penny? 0.72. The next digit is a 1. So 18,772.72. The normal rounding off rules, right? The normal rounding off rules are if the next digit is 0, 1, 2, 3, 4, leave it at 2. But if the next digit is 5, 6, 7, 8, 9, then you go up and make it 0.73. Right? The usual rounding off rules. And that's the way it works. Okay, now for those of you that have this kind of calculator, you might have to go backwards. So you have to do 1.05 to the 16th power first, I think. Okay, so let me try it on this calculator. So I'm going to hit 1.05. Exponent is y to the x power, sometimes x to the y. 16 equals, okay, there it is. And then multiply that by what? 8,600. So times 8,600 equals, and there it is, same thing, 18,772.72 rounded off. Always round in the nearest penny. So if you don't round in the nearest penny, you automatically lose some points. Okay? You can't put the one, you know, we don't have money that goes out that far, right? We have $18,772.72, but we don't go out to 146 or whatever, right? So there we go. Okay. It says 10, but that's 12 in this book. Offset here. 12. What interest will be earned if 6,300 is invested for 3 years at 12% compounded monthly. Okay, so your principal is $6,300. Your annual interest rate is 12%, and compounded monthly for 3 years. Okay, so it's a little bit trickier also because it asks for the interest. So there's more to this than meets the eye. Okay, so your principal is $6,300. That gets plugged over here. All right, and once again, 12% compounded monthly. That means I divide this by 12. 12% divided by 12 is 1%. As a decimal, that's 0.01. So the I that I'm plugging in is 0.01. The N is 36. You say, how'd you get to 36? Okay, 3 years. Monthly means how many times a year? 12. 3 times 12 is 36. So you see what's happening? You have to figure out the I and the N because of the chopping up. So don't just automatically plug in the interest rate. Take the interest rate and divide it by something, right? If it's annual, you don't have to divide by anything. Just keep it, right? So if it said 12% compounded annually, just put 0.12. Semi-annual, divide by 2. Quarterly, divide by 4. Monthly, divide by 12. And most of the time you have these. I don't think they're going to give you any 365. Even though that happens in real life, the numbers get real bad. The numbers are so messy that we decide not to do that. Okay. All right, so here we are, $6,300. I plunked down $6,300 to the banker, 1.01. So the I is 1%, not 12% because it's chopped into 12 pieces. The N is the total number of periods, which is 3 times 12 or 36. And that's what I got, 9013.84. And let me show it to you, 6,300 times 1.01 exponent 36. 9013.843. 843 again means just 84. So there we go. Okay, now something else that's a little bit tricky. The original problem asked for the interest. What is the interest? Okay, you started with 6,300. It's now worth this much. The difference is the interest, right? So I just subtract. Okay, so one more time, you plunk down to the banker. Okay, banker, here's $6,300, and now it's grown to 9,013.84. So the difference is the interest. So I just subtract 9,013.84 minus the 6,300, 2,713.84. Okay, that's considered interest. And yes, in case you're wondering, that is considered taxable income. So you would have to report that as income to the IRS and Franchise Tax Board for income. Okay. All right, next one's a little bit different. It's 14 here on my paper, it says 12, but anyway. What lump sum, 14, what lump sum should be deposited in an account that will earn 9% compounded quarterly to grow to 1.2 million for retirement in 25 years? Okay, this game's a little bit different. You want the future value to be 1.2 million. We're not depositing 1.2 million. You know, most of us can't do that. But you want it to grow to 1.2 million. So the 1.2 million is the future value. We're asking, what amount do I deposit now? What's my starting deposit so that it will grow to 1.2 million, blah, 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 blah. Okay, so here's the important data. 9% compounded quarterly. 1.2 million, that's 1200000, and it says 25 years. Okay, so you hope to retire in 25 years. Under this scheme, how much do I have to deposit right now? Okay. So the 1 million, whatever, 1.2 million, that goes right there. That's 1,200,000. We need to find the principal. Okay. Now, find the I and the N. 9%, it said quarterly. Quarterly means divide by 4. By the way, if you want to put this on your cheat sheet, you may put that in your formula sheet. Okay, so 0.09. Remember, 9%, don't put 9. You got to put 0.09 divided by 4. So 0.0225 on your calculator. Okay, 0.0225. And what's the N? 25 years. How many times a year for quarterly? 4. So 25 times 4 is 100. Okay, so 100 goes there. The I was what? 0.0225. Okay, so right now the formula looks like this. 1,200,000 equals principal 1.0225 to the 100th power. Solve for P by dividing both sides by 1.0225 to the 100th power. Let me raise it up for you. And maybe you couldn't see this either. So if you're looking at the video later, there's that. So solve for P, divide by 1.0225 to the 100th power. And there it is, supposedly 129,673.01. Okay, and let me see if I can demonstrate to you that. Okay, so 1,200,000, 1,200,000 divided by 1.0225 exponent 100. $1,29673.005. Since this is a 5, it means you round up to 0.01. Right? Yeah, not much of a difference between 0.00 and 0.01, but you're supposed to have that penny. I mean, if you get a chance to get that extra penny, you want that penny, right? Okay, give me that 1 penny. And by the way, that 1 penny might seem trivial, but not to the banks and some institutions that have thousands and thousands of customers. You know, if they all get that extra penny, it adds up after a while. So 1,29673.005 means 0.01. So that's why I got over here. Okay, then I was going to show you one more. So if I can't find where this problem is. It says 25, which is my 23. Okay, and we didn't even have to go that high. But that's okay, it's a nice problem anyway. So I'll do what's 23 here just for practice, as it were. Okay, what investment will earn more money? A $1,000 investment for 5 years at 8% compounded annually. Okay, so we're just going to do that part. I'm not even going to look at this. So if you're following what I have in the book, skip the part that says compounded continuously. We're not doing that. So I do want to show you one example of compounded annually. Annual compounding. So that's all I'm going to show you. Before doing that, I will just mention this. You don't really have to know this, and it doesn't affect the test. But in case you're wondering, okay, if you have, let's say, annual, monthly, quarterly, investing at 8%, or whatever the percent is, under which scheme do you actually end up with more money per year? It goes like this. Okay. Meaning, if you have 8%, compounded annually is not as much as if compounded monthly, which is not as much as compounded quarterly, which is not as much as compounded monthly, and so on. In other words, suppose you said 8% annually, 8% once and for all, that's it. I know I didn't put semi-annual, but just giving you the idea. If it's semi-annual, 4% twice a year. You might think it's the same, but it's actually not. You can show by plugging into the formula, you actually get more money the more compounding periods there are. Okay? And if you have Actually, this is a mistake here. Sorry, these two should be switched. Right, annually, quarterly, monthly. Okay. So quarterly, you get more than semi-annually. And monthly, you get more than quarterly. And then daily, you get the most. Okay, sorry, I messed up here. Okay. In other words, the more periods you chop it up into, the more money you actually get. And you can show that. Okay. And daily, you get the most. So if you chop it up into 365 pieces, which is a very small number, but you get it 365 times a year, you actually end up with more money. Okay. So I just wanted to say that offhand. Okay. So anyway, this one, I was just going to show you what? $1,000 investment, 5 years, 8% compounded annually. So P is 1,000, annual is 8%, compounded annually. You don't chop it up in anything. So this time you literally put the 0.08. So in this circumstance, you're not chopping it into 2 or 4 or whatever. Keep the 1 plus 0.08, so that's 1.08, raises to the first power. Okay, and there it is, $1,080. Okay, and just for illustration purposes, I went ahead and did quarterly and monthly, just to prove this to you. Okay, quarterly, divide by 4, 0.02, right? N is 4. So I punch this in the calculator. 1082.43. It's a little bit more. Monthly, 0.08 divided by 12. It's 0.006 repeating. You guys know the bar? It means repeating. It's 0.006666 repeating. Okay, here's your 0.08 divided by 12. 0.0066. Well, it rounds off to the 7, but it's literally an infinite amount of 6s. Okay, and n is 12. So it's 1.006 to the 12, 1083. A little bit more. So they're not all equal. So annual compounding, 1080. Quarterly, 1082.43, a little bit more. Monthly, 1083, a little bit more. And there we are. All right. Okay, I'm done with the lecture formally, folks. So I'm knocking this off. So unless anybody has any questions, we're finished. What time is it? 6:35. We got plenty of time. Okay, so if you have any questions on either 6.1 or 6.2, you may ask it now. But otherwise, we're done. So let me check the chat real quickly. Let me stop the share. Anything in the chat? I don't see anything in the chat. Okay, some of you joined late. Okay, I'll get that a little bit later. Okay, so any questions about anything, about what we did? You can ask me stuff from what we had. Okay, if not, then the homework again, finish 6.1 and 6.2. Next time, I showed you the schedule. We're doing one section a day, so 6.3, 6.4, 6.5, leading up to the second test. All right? Any other questions, please? All right, that'll do it then for tonight, folks. All right, so have a good evening, and we'll see you next time. Have a good weekend, and see you next Tuesday. Okay, bye, everybody.
Thank you.
Thank you,
Have a good
Professor.
night. Thank you.
Bye.